All right. So chapter one never ends. So if I was to set the chapters, chapter one actually would end at the end of 1.4. So all of that was linear equations in one variable in a complete package. So we looked at expressions, we solved equations, we had literal formulas, and then we had applications. What we're going to do next is 1.5, 1.6, and 1.7. 1.5 is going to be linear inequalities in one variable. 1.6 is going to use some of this concept of inequalities in a totally different way. And then 1.7 is its own little microcosm. So it's a long chapter. Bear with me. The skills are the same, which is why they are together, but it's going to feel a little bit different. So we're moving on from linear equations in one variable to linear inequalities in one variable. To be an inequality, instead of using an equal sign, we use a less than or less than or equal to, a greater than or a greater than or equal to sign. But we're still doing the same thing. We're finding the values of x that will make the inequality true. So for example, if I said that the solution is x is all real numbers less than or equal to 2, what are three solutions that would fit? Well, 2 is an answer that's less than or equal to 2. 1 would be a solution that's less than or equal to 2. So would 0. So would 1.5. So would 5/6. So would -5/6, right? There's tons of solutions that are less than or equal to 2. And they're not all integers, right? They could be irrational or rational numbers. And this is dot, dot, dot. So this said just state three solutions. I stated 6. So are there more? Yes. There's an infinite number of answers. So what we do for linear inequalities is we write the answer as a general statement, something like x is less than or equal to 2. And then we know that x can be multiple things. They just have to be less than or equal to 2. But we have two other ways of displaying this answer as well. So when you are presenting the solutions to an inequality, there are three ways of presenting the solution. Number one, we call set notation. This is just an equation using the variable and the inequality symbol. X is less than or equal to 2. That is set notation. To make it proper set notation, we could put the set brackets around it. To make it a full sentence, we could say the set of X such that X is all values less than or equal to 2. There's lots of versions of set notation, but reality or the nitty gritty is that this is set notation, writing your variable with your inequality symbol. But this doesn't really, it tells us the answers, but sometimes it's nice to have a visual display of the answers. So a graph is a great way of showing visually what the answers could be. So you use an arrow or a line, well, an arrow and a line, that shows the direction of the solution. And then you put either a round bracket or a square bracket at, for example, the 2. If you use a round bracket, that indicates the endpoint is not included in the solution. In other words, I can't write, is not included in the solution. For example, it's greater or less than. If it's a square bracket, it means it is included. So that would be something like less greater than or equal to or less than or equal to. Then there's interval notation that is really just your graph, but without the number line. And we introduce things like infinities, which show you where the numbers go to. Now you'll always use a round bracket on an infinity symbol because you can't be equal to something that isn't concrete, right? We don't know what infinity is. So let's practice a bunch. So the first thing we're going to do is x is less than or equal to 2. In set notation, it would be x is less than or equal to. So when I read my inequality signs, because this is the smaller end of the inequality, I'm like x is less. Whereas if I was reading it from this side, it would be greater because I'm talking about from the bigger side. So x is less than or equal to 2. As a graph, you would put 2 somewhere on the number line. I don't care where. Okay, and I don't put all the other numbers. I literally just put the number that I'm talking about. And then I know that the numbers go less to the left and greater to the right. Now, less than or equal to is going to be a square bracket because I can be equal to. And because it's less, I'm going to have an arrow pointing to the left. So from 2, all of these numbers are less than 2. To show that I could be equal to 2, I'm going to use a square bracket to close it off. The way I remember whether it's a round or a square bracket is that, see the equal to sign there, right? If you do a square bracket, you've got that equal to sign in it, whereas the round bracket means that it's not equal to. And then interval notation takes this graph and says, well, where am I going from and to? This graph is going from 2, and then where is it going down to? Well, down here is negative infinity. So this graph is going down to negative infinity. So interval notation is the graph without the number line. So you have to show where it's going. Let's try another one. What about x is greater than 5? So x is greater than 5. For the graph, I'm going to put a 5 somewhere on the number line. Again, I don't care where. So the graph's kind of an intermediate step between set notation and interval notation. Generally, in math, people don't give graphical representations all the time. They often just do interval notation. So x is greater than 5. These are the numbers that are greater. So greater is always to the right, less is always to the left. And because I can't be equal to, I'm going to use a round bracket. Now for this one, for interval notation, I would take away the number line and say that the numbers are starting at 5, and where are they going to? Well, they keep going to infinity and beyond. So up to infinity, and always a round bracket on infinity. All right, so the other variations would be less than or greater than or equal to, but really all that changes is whether you have a square or round bracket and which way the arrow points. We're going to go through 4 more examples, not necessarily for today's lesson, although the next 2 are for today's lesson, but to prepare us for tomorrow's lesson as well. By tomorrow, meaning 1.6. So the first one is x is all real numbers. Now, we talked about this when we got the solution to an identity in 1.1. When x can be anything, we say x is an element of the real number system. This would be set notation, right? X can be anything. On a graph, it would mean the entire number line from negative infinity up to positive infinity. So we'd go negative infinity up to positive infinity in our interval notation. The other one would be, what if there's no solutions for x? Oh, well, that's just empty set brackets. There'd be nothing on the graph. And since there's nothing on the graph, it's null. The graph doesn't exist, right? So set notation solution, interval notation solution. And then the last 2, like I was saying, they're just to prepare you for 1.6. You're not going to need them today, but I was like, well, do I put this on the next lesson or do I just put it all here? So in this one, what I want to show you is just if there's 2 boundaries. So this is going to say that x is all real numbers greater than or equal to 1 and less than or equal to 7. So we've got 2 numbers to put on my number line. We have a 1 and a 7. Now, x is all real numbers greater than or equal to 1, which would be this way. That's greater, right? Pointing towards the 7. And less than 7. Less than is a round bracket and with an arrow going to the left. So this is what I call an x sandwich. X is sandwiched between the 1 and the 7. And for this one, I went straight to the graph because I find it useful to do set and interval notation from this graph. So for my set notation, x is sandwiched between 7 and 1. And for my interval notation, x is everything from 1 to 7. So round bracket, right, not equal to, square bracket equal to, and just pulling it off the graph. And then the last one, again, just to prep us, and we're going to learn more about this next day, but what if we use the same 1 and 7, but this time we're going to say that it's all numbers less than 1, so we're changing to a round bracket to the left, or greater than or equal to 7 would be a square bracket going to the right. Now, for my set notation, I personally would say x is less than 1 or greater than or equal to 7. Some people might argue that you could do it like this. So x is greater than or equal to 7 x is less than 1, that would be fine as well. We don't often do set notation for these. But what I want to show you is that for interval notation, this answer is going down to negative infinity. So it'd be negative infinity to 1, or it would be square bracket 7 up to positive infinity. So again, these two we don't need today. This will be 1.6, but I thought why not show it in the grand scheme of things. But today what we're going to do, or in this lesson, what we're going to do is practice just these 4 answers.